Alright, we're looking at 0654, Winter 2018, paper 4.1. Okay, so question 3, you should be used to this by now. Question 3 tends to be a physics one. We're firstly asked to draw a circuit diagram. Okay, again, something that people miss. It's just the simple command there, and I've seen students leave this question empty. It's a shame, as it's 3 marks. That would strike me as an important one. Okay, you're told that we have 4 cells, and then you've got 2 lamps, X and Y. What I've done is I've drawn the symbols for a cell and a lamp above there, so that reminds me I don't need to think about this. Reduce the difficulty in my brain. I've also drawn what a switch looks like as well. Okay, and then I'm told that the 4 cells are connected in series. Well, really 4 cells connected in series. 1, 2, 3, 4. This is our battery now. Battery is just a collective term for cells. Okay, and they are connected in parallel with the 2 lamps. So there we've got the 2 lamps connected in parallel. Alright, each lamp has a separate switch, so we need to put a switch in series with each of the lamps so that I can turn those on. This is just like your lighting circuit in your house. Okay, if I'm in the living room and I'm in the bathroom, I could turn the living room light on without affecting the bathroom light. Okay, 3 marks for that. You're then asked, you're told, some current, that's my I, and resistance R. Again, they tell you these things for a reason. You're never told any information in these questions for no reason at all. So draw a circle around them, write the symbol, do something which makes you remember those things. Okay, you're then asked to calculate the total potential difference supplied by the cells, i.e. the potential difference across our lamp X. Yeah. Notice these questions are a bit older. This is from 2018. You're asked to write down the formula and do the working. Okay, this is absolutely spoon-feeding this to you guys. Okay, you're asked it down here as well. You need to work out if you need that prompt or not. Later papers don't have it. Okay, we've got I, we've got R. We're being asked to calculate V. Okay, V equal to IR, Ver. All right, 0.5 times 12, 6 volts. That seems like a reasonable number for our potential difference, especially when you consider we've got 4 cells here. So that means if I've got 4 cells, each one's giving me 1.5 volts. That's definitely the kind of number that you provide from a cell. You're then asked to calculate some charge, that's Q. Well, we know I and we know T, and again, this thing's happening and this comes up again and again, specifically 2 minutes. You're told time in minutes. We know that time SI unit should be seconds. Yeah. So please make sure you've done a conversion. 2 times 60, 120 seconds. You've got an I, 0.5 times 120, 60 coulombs. All right. We then go straight off onto a completely different topic, which is our light reflection. Okay, you're being asked firstly to complete the figure to show the ray of light reflecting off the mirror. All right. Now, I've just realised I need to go and grab my protractor. Give me 1 second. There we go. I would suggest that this is the kind of situation where you should invest in a protractor. All right, because obviously what you have to do here is you have to draw a line which comes firstly onto the mirror and then reflects. Now, how well you draw that line is going to really depend on having 2 instruments at your disposal, a ruler and a protractor. Those are the kind of things that are never going to be guaranteed available for you. Go and buy one, you never know, it's worth 2 marks. That could be the difference between an A and a B. Okay, I've drawn my incident line already for you. Okay, I've found that it comes onto here. Yeah, it hits my mirror at that point, and then after that I've drawn my normal. Okay, normal is obviously important because the way that you measure your angles is from the normal. Okay, here's where I need to lift up the camera very quickly just to make that a bit easier. Now, what we're doing there is we are measuring our angle of incidence. Okay, you notice here my normal's all down the center line. my ray comes in here, and that's coming in right on an angle of 45 degrees. And you'll see later in the question that's the angle that it should be. Okay, therefore this angle here, my angle of reflection, also needs to be 45 degrees. If you come round here, we can measure around here 10, 20, 30, 40, 45. It's somewhere there. Okay, all I now have to do is connect my normal to my reflected ray. Okay, that is going to be a really nice answer for this question. It's going to guarantee me the marks. Okay, and also it's helped me work through the next parts, because it then says, well, it says firstly, show the light reflecting. We've done that. Mark and label the angle of incidence. Well, that's the angle of incidence right there. This is the angle of reflection as well. We want it just to be completely over the top. It then says state the angle of reflection. Well, we've just said they have to come off at the same angle. I equals R. So therefore, this is 45 degrees. Then this also must be 45 degrees, because in reflection, the angle of incidence is equal to the angle of reflection. Okay, that finishes that question.